Hello, in this video we will solve question number 4 of first internal test document. So in this we are given the question is to give the production rules in Baker-Snauer form for an identifier if it consists of, we are given 4 questions and we have to define a grammar in Baker-Snauer form for these production rules for these. The first one we are given is one or more lowercase letters. So to represent one or more lowercase letters, we can have a first we can replace identifier directly with a letter as we can only have one letter, and if we have more we can recursively call this non-terminal again with a lowercase letter, and lowercase letter will be replaced with a to z any small lowercase letter. So this is the Baker-Snauer form grammar for this. The next we are given is at least 3 but no more than 6 lowercase letter. So as we require at least 3 and not more than 6, so we can directly define these by just writing again and again the letter non-terminal, lowercase letter non-terminal. Like in this, I have used identifier with we require at least 3, so I have started with at least 3 with lowercase letter, and then or operator, and then 4 and 5 lowercase letters can be there, and 6. If we do not have more than 6, we can end this with and this here, and the lowercase letter can be replaced with a to z any lowercase symbol. The third one given question is 1 to 6 uppercase letter or lowercase letter beginning with an uppercase letter. Okay, so we can have at least one uppercase letter, so identifier can be replaced with uppercase letter, or we can have 1 to 6 uppercase letter. So I have replaced uppercase identifier with uppercase letter and letter, and the letter can be replaced with LC lowercase letter and uppercase letter. And as we have up to 6 uppercase letters, so I have defined letter again and again for at most 5 times, and we have at least one uppercase letter. I have started with a uppercase letter non-terminal, and as you can see, letter can be replaced with lowercase letter or uppercase letter, and lowercase letter can be replaced with a to z, and uppercase letter can be replaced with capital A to Z. The fourth question, the 4D one is the question is a lowercase letter followed by a digit or an underscore followed by 3 or 4 alphanumeric characters, lower or uppercase letter and digits. So it requires a lowercase letter. So I have rule that replace identifier with lowercase letter followed by a digit or underscore. So a digit can be replaced with digitaurus, and digitaurus as I have replaced with digits, digitaurus, and then alphanumeric that, and it has followed by 3 or 4 alphanumeric. So first it has 3 alphanumeric characters to represent 3 alphanumeric, and I have another rule that replace identifier with lowercase letter, digitaurus, and 4 alphanumeric characters, as we can only have 3 or 4. I have two rules that replace identifiers with this. Then digitaurus can be replaced with digit, and alphanumeric characters can also be letter or digit, and letter can be again can be a lowercase letter or uppercase letter. The lowercase letter can be small a to z, and uppercase letter be capital A to Z, and digits can be replaced with 0 to 9. Another question we were given is give the production rules in Baker-Snauer form that generates all identifiers in the C programming language. It can identifier starts with a letter or an underscore that is followed by one or more lowercase, uppercase letter, underscores, and digits. So I have written the grammar for this. As you required, identifier can be replaced with letter or s, which can be replaced with a letter. Identifier with letter or s or identifier symbol. as we can have multiple symbols, therefore I have called it a recursive. Then we have letters can be replaced with letter, symbol can be replaced with letter or a digit. A letter can be replaced with lowercase or uppercase, as we know. Lowercase are small a to z, uppercase letters can be capital A to Z, or digits can be 0 to 9. The next question we were given is to give the production rules in extended NOR form that generates all the decimal numerals consisting of an optional sign, a non-negative integer, and a decimal fraction that is either the empty string or a decimal point, followed by an optional positive integer, optionally preceded by some numbers of zeros. So extended Backus NOR form provide us with provide us with a little power, as we can represent production rules that contains an optional symbol, and we can represent this optional symbol by writing question mark at the end of that symbol. We can also write star to represent if this symbol can be represented from 0 to infinite amount of times, or we can represent plus, which represent it will be represented for 0 time or 1 time at least. So in this example, as we need an optional sign at the start, we can write sign and question mark to represent an optional. Then we require a non-negative integer to replace it with non-zero digit, and then we can have multiple digits, therefore we have represented star here. Then we can have a decimal fraction, and it is optional also, therefore we write question mark. And also numeral can also be replaced with an empty string or a decimal point, and therefore we have a string question mark, then 0, then decimal question mark. As there are as we require to have positive integer optionally preceded by some number of zeros, therefore we have 0. Then sign can be replaced with minus, plus and minus, plus or minus. Non-zero digit can be 1 to 9. Digit can be 0 or a non-zero digit. And decimal can be a digit star, point digit star. So it will start with a point, then a digit, and it can have multiple digits after the point. Thank you.